In this video, we're going to take a look at the concept of average rate of change. So let's say that we have a function, and I'm just going to draw a graph of some miscellaneous function, something that looks like this, let's say. And we take 2 points on the graph of this function. Here's a point right here. Let's call this the x value of this point. We're going to call A. And here's another point here. The x value of this point we're going to call B. Well, the function value of A would be along the y-axis over here. That would be the y value or the function value. And for point B, the y value or the function value would be along the y-axis over here. So we have point A and its function value f of A, point B and its function value f of B. Now, if we take the difference between the two function values, f of B minus f of A, and then we divide that by the difference between A and B, we have what is referred to as the average rate of change between these 2 points, which I'm going to abbreviate AROC, the average rate of change between A and B, which we will quite often just put using interval notation A comma B with brackets. So this is the average rate of change of this function over the interval from A to B. Well, an interesting thing about this formula here, the average rate of change formula, is that it looks very similar to the slope formula between 2 points. Remember that slope, which we usually use an m to represent, is the difference between two y values divided by the difference between two x values. Well, that's exactly what we have here. The function value f of A and f of B are really two y values, and A and B are really two x values. So this is the slope of a line. And so because these two formulas, the slope of the line between 2 points is the same as the average rate of change formula, we can say that the line drawn between these 2 points, which is called a secant line, represents the average rate of change. So this is what is called a secant line. Secant line simply means between 2 points. So the slope formula gives us the slope of the secant line between A and B, and the average rate of change formula gives us the average rate of change. So consequently, we have two things here. Two very important things. We found out that f of B minus f of A has two meanings. Whoops, divided by B minus A has two meanings that are very important. Number one, it is the average rate of change over the interval from A to B. And number two, it is the slope of the secant line over the interval from A to B. So let's just do one quick example here, show how we kind of put all of this together. So let's just say that we have a function f of x is equal to x squared plus 1. And we have the interval from 2 to 5. Now, it's not necessary to graph this to understand the problem, but we could graph it. We could either graph it by hand or we could graph it using Desmos. But we're not going to do that right now. And we want to find the average rate of change of this function between those 2 points. Find the average rate of change of f of x over the interval from 2 to 5. So let's start by using our formula. Average rate of change is f of b minus f of a over b minus a. All right, well, what is the function value at b? Well, here's our function, so let's plug b in there. So we would have 5 squared plus 1. That is the function evaluated at b minus the function evaluated at a. So we have 2 squared plus 1. And then all of that is divided by 5 minus 2. Well, 5 squared is 25 plus 1 is 26. Minus 2 squared is 4 plus 1 is 5. All over 5 minus 2, which is 21 over 3, which is 7. So the average rate of change of this function over this interval is 7. We can also say that the slope of the secant line, the slope of the secant line of f of x equals x squared plus 1 over the interval from 2 to 5 is 7. All right, so these two interpretations of this formula are very important and are going to be leading to another concept that we'll be learning in a future video.